This is Chapter 6 from Mastering ArcGIS by Maribeth Price, copyright 2011. Chapter 6 is about spatial joins. First of all, what is a spatial join? We look back to attribute joins where a FIPS in this case was used to join two fields, a destination table and a source table. Notice how the source table is appended to the destination table. The name is carried over. And in this case, the FIPS 27077 is right here, and then the information is appended onto it based on, for example, Lake of the Woods. And population is added to this table, population 2001, 2000, etc. This is the joined table. Spatial joins are a little bit different. It combines a destination feature class and a source feature class, but it's spatially joined. And that is shown by this diagram where we have a cities 2 combined with the combination of cities and airports. Two joined tables based on a common spatial relationship. For example, one feature inside another, one feature closest to another. A distance spatial join appends record based on which source feature airport is closest to the destination feature city. Meaning which airport is closest to the city, judging by distance. An inside join appends a record of the source feature, geology, to the destination feature, septic, that falls inside. So in this case, the geology is tied to the septic of what actually is on the septic site. For example, a gravel deposit or a Minnelusa formation. Cardinality. What if you switch the destination to airports and the source to cities? Each airport is serving many cities, and the cardinality is now 1 to many. The rule of joining is violated and no join is possible. If you could instead use summarize to group the cities according to the airport they served and sum the population, you would get the table to the left. Now every table has one record. You can do this with a summarize join. Normally you'll use a 1-to-1. And as a reminder, the spatial join cardinality, the rule of joining applies to spatial joins as well. Simple joins, a 1-to-1 or many-to-1 cardinality, will work. But summarized joins are required for 1-to-many or many-to-many. A simple spatial join, 1-to-1 or many-to-1. There is no ambiguity in assigning fields. Point-to-point joins. These can be done by distant joins only. Which attraction is closest to each hotel? It enforces a 1-to-1 cardinality because it's closest. How many attractions are closer to one hotel than another? That is a 1-to-many cardinality, and you must use the summarize, not a spatial join. What are the types of spatial joins? I will tell you that right now that we do not use summarized spatial joins in 3.11, so I'm going to focus on the simple. Counties to school. Which county is each school in? That's the inside. Or distance. Which attraction is closest to each hotel and how far is it? Feature geometry and spatial joins. A distance points to polygon. You can join each county to the hospital that is nearest it. Each county feature gets the name of the closest hospital and the distance. And as you can see down on the bottom, most counties in South Dakota do not have a hospital, and we need to know the hospital closest to each county and how far it is. The hospitals have been joined to the county polygons within the counties as the destination table. The distance join is chosen. The output shapefile always has the same feature type as the destination table. Polygons in this case, because we started with polygons. After the join, each county has a field indicating the name of the closest hospital, as well as the distance from the county to the hospital in decimal degrees in this case, because that is the distance that is shown. That was in the table in the beginning. And then a unique values map was created based on the hospital name. In the northeast part of the state, it's easy to see that the pink counties are closest to the hospital in the pink areas, the yellow counties to the yellow hospital, and so on. Note on polygon distances. In measuring distances for polygons, the centroid of the polygon is used, and that means the center of the polygon. For each of the counties, the centroid of the county is closest to the hospital. If the county contains a hospital, the distance is 0. Pennington County has 3 hospitals, all within a distance of 0, so one is randomly chosen to match. Points to lines. In this example, we wish to evaluate the impact of septic systems on various streams based on distance. Streams is the destination. Each point represents one or more septic systems. We find the number of septic points closest to each stream segment and summarize the totals. What assumption is being made here, and how valid is it? That's something to think about. We're not using the summarize in this course, but this is interesting to think about what the book is trying to get at there. Feature types. Every join involves 2 geometry types. Points to points, polygons to lines, lines to points, etc. Each combination offers 2 possible join types. One is usually a simple join, and the other is summarized. In the next examples, we break with our usual convention and put the destination layer on the right. This is done to match the convention used in the ArcGIS join menu. The destination table is shown in boldface. Several possible combinations. Points to points, you can use simple distance and find the hospital closest to each town. Lines to points, you can use simple distance and find the water main closest to the proposed building site. And polygons to points, simple inside, find the soil type that underlies each gas station. Points to points, destination, hospitals. Simple distance, find the source feature that is closest to the destination feature. Find the hospital closest to each town. Polygons to points, destination, hospitals. Find the county that is closest to each hospital and give the hospital the county attributes. Polygons to lines. Find the park that is closest to each road and give the road the park attributes. This is a polygons to polygons. The simple inside gives each urban area the attributes of the county that it falls inside. So all of the county attributes would then be appended to the urban area in this example. Find the park that each lake is inside and give the lake the attributes of the park. These are just some examples of the possible combinations. There are many others shown in your text. ArcGIS figures out the 2 possibilities and presents you with a choice. One usually makes sense after a little bit of thought. And that's the beauty of ArcGIS. It helps you make the decisions. Coordinate systems and distance joins. We'll discuss coordinate systems in a future lab and future weeks, but let's just touch on it here. A source coordinate system. Look at the join of the hospitals to counties. What happens if the source layers are in a geographic coordinate system? And this is what happens. We get the distance in a decimal degrees, which isn't too easy to understand. The source data were in a geographic coordinate system with units of decimal degrees. The distances are given in stored units. Decimal degrees cannot be easily converted to miles or kilometers because the conversion factor varies with the latitude. It's better to use a projected coordinate system, which is why we'll 99% of the time use a projected coordinate system. You don't need to know exactly what that is at this point, but we will be using them, and you can recall this when we get to that portion of the course. This slide is interesting as it shows distance joins in the coordinate system. Distance joins with the GCS, Geographic Coordinate System source. It shows where things would start to line up, and in this case the items are moved about because in the Universal Transverse Mercator source the features would be in a different area based on the coordinate system transformation. So just be aware that this is showing that things move if you use a different coordinate system for each item. The data frame coordinate system may be different from the source data coordinate system. Setting the data frame coordinate system is not enough to fix the problem. You must project the source data using the project tool, and again we'll talk about this in chapter 11, and do the join again. And this is exactly why we never let ArcGIS project on the fly. You will learn more about that later, but just remember, do not project on the fly, and setting the data frame coordinate system is not enough to fix the problem. We must project the source data at all times and always make sure they line up. How to join. We right-click the destination table, set the join type to Spatial, choose the source table, choose the join type, and then specify the output file. In this case, this was right-clicked, joins and relates, join, and then we have the join data. And we choose based on location or attributes and set the information. There are two choices. Based on the two geometries in the destination, ArcMap PIP picks the possible two join types. You just need to pick the correct one, and usually it's easy once you see the choices that you are provided. Summary statistics I'm going to skip because we don't use them. Setting up spatial joins. Sketch the layers. How do I want the output layer or table to look? Which is the destination layer? Is this a distance join or an inside join? And what is the cardinality? Do I need a simple join or a summarized join? Example 1. Find all congressional districts that have had more than 10 earthquake deaths. And we can open this up a bit so you can see. Imagine you work as a staffer for one of the congressional districts in California. Your representative is sponsoring legislation to provide earthquake emergency planning funds. So that's where we're looking to get that information. Choose the layer to join to this layer, or load spatial data from disk, and we have quake set already, and that looks like they're going for a sum. How do I want the output to look? What is the destination layer? Is there a distance join or an inside join? And what is the cardinality? Do I need a simple join or a summarized join? And again, going back, find all congressional districts that have had more than 10 earthquake deaths. So this is an inside join. Example 2. Develop a pollution risk index for rivers based on the total number of people in the adjacent counties. This would be a distance. The layer that we're joining to this layer is counties. In this case, we're doing polygons to lines, and the attributes from the polygons are being appended to the river counties. In the final example, we create a table showing the volcano closest to each city in the United States. In this case, we're creating a city volcano layer based on the volcanoes, and it's going to tell us the distance from the volcano to the cities. And of course, the cities are here in the name column. That wraps up Chapter 6 of Mastering ArcGIS by Maribeth Price, 5th edition.